Okay, so we are doing, let's see here, not this section. Let's find the right section. Go back a page, right here, down here. I am doing 6.3, number 4. So this one here, and I actually better write that down. I didn't write that down for myself, and then I'll be wondering what it is. So x equals y to the 3 halves divided by 3 minus y to the 1 half from 1 to 9. Okay. So the first thing you want to do on all these arc length problems, remember that's that funny formula, the whole radical and things. And the first thing you need to do is you need to remember the formula for here is from a to b of whatever we're doing, the square root of 1 plus y prime squared dy. Okay, so this is formula for arc length. So what I need to do is I need to first figure out y or x. So I'm going to raise y to the 3 halves divided by 3 minus y to the 1 half. So x prime here, let's see here, 1/3 times, bring down the 3 halves, subtract 1. Over here, bring down the 1 half, subtract 1. Okay. So do a little bit of cleanup. Prime, those 3 cancel. 1 half y to the 1 half minus 1 half y to the negative 1 half. Now I need to figure out what the radicand is. So this under here. So to do that, what I'm going to do is I'm going to do 1 plus 1 half y to the 1 half minus 1 half y to the negative 1 half squared. So this is 1 half square root of y minus 1 over 2 square root of y times itself. Okay? So I'm foiling out. I'm going to get 1 plus, let's see here, 1/4 y, the two radicals will cancel out. And then here, the y squared, so I'm going to get negative 1/4 and another negative 1/4. Finally, a plus 1 over 4y. Okay, so then this plus this, that's 1 half, subtract it. I have here 1/4 y plus 1 half plus 1 over 1/4 with the y in the bottom. So this means what I'm actually doing is I'm going from 1 to 9. 1/4 y plus 1 half plus 1/4 y. This is all under the square root sign dy. Probably going, I don't know what I can do with that. So this is where all those algebra tricks are coming back. Those algebra tricks we told you, you need to know those. So I'm going to pull a 1/4 out here. I'm going to have y plus, this is going to become a 2 plus 1 over y dy. Okay. Now, at this point, I have this. Then what's going to happen is this is a perfect square binomial for this. And this is one of those things you just kind of got to play with something until it works. Chances are, if you look at this, this is going to factor somehow. You just have to figure out how. And in this case, we don't have any squared. Normally, we're used to looking at something like, remember when you had those x squared plus 2xy plus y squared? Remember these back from factoring 101? That's what this is. Only instead of x squared, we have y's, so they're y squared. But that's what this is. And how I recognize it is, well, I really have the same thing in the beginning and the end. So it's like I have those squareds. And in the middle, I have a 2. That tells me I can probably somehow make it work. Just have to figure out how. Once you get to this point, and most of the ones in this section, you'll see this repetitively. So I'm pointing out this trick because you're going to need it again. You can just take the square root of all this. This is 1 to 9. That's 1/2 times the square root of y plus 1 over the square root of y dy. And then I can even bring this 1/2 out. And this is y to the 1/2 plus y to the negative 1/2 dy. Yeah, as usual, it's going to go all kinds of crazy places. So from here, I now need to take the integral. So I'm going to be adding 1 here and 1 here. So I'm going to actually write this down because I have to go back to the top of the page. I try to make a couple of pages because it links to I'm not really sure. Something I'm doing wrong. I fully admit it's user error. I just don't know what the user error is. So then I have 1/2 times, let's see here. I'm adding this is 2/3 y to the 3/2 plus, and that's going to become a 1/2, so 2y to the 1/2. And this is all evaluated from 1 to 9. So then I have 1/2, 2/3 y 9 to the 3/2 plus 2, well the square root, that's 3. I don't even have to work that one out. Minus 1/2, well 2/3 plus 2. At this point, I would recommend get out your calculator and start putting. So 9 to the 3/2 is 27. So then I have 1/2. Those are going to cancel. So that's going to become 18 plus 6 minus 1/2. Well, 2/3 plus 2. This is 8/3. Okay, and oh, good, I didn't get out. I'm like, how'd I run out of room already? So then 18 plus 6 divided by 2 is 12 minus, let's see here, it's making a 4 minus 4/3. So 12 minus 4/3, which gives me 32/3. So this is my arc length. And I drew somewhere, let me find it here. Here's the picture, and you can see then going from 1 to 9 out here, 9 here, approximately. Then that idea, that length of that curve between those two is this, 32/3. So you can see the hardest part of this is going to be taking the integral. Taking the derivative, no problem. Taking the integral is going to get quite messy. You are often going to have to perform some sort of algebra trick to get it to the point where you can take the integral. And the one I showed you here is the most common one in this section. That's why I'm showing it to you. So as you look at this, think, how can I use this perfect square binomial? And the reason we want perfect squares is because then when I take the radical, it just goes away. So that's my goal. Somehow get it. It's back to the same reason we learned completing the square. We want to somehow rewrite it as a perfect square binomial, and we just have to do a little jury rigging to make it work. And in this case, it's using these radicals.